Welcome to the sixth part of the webinar on the EICASLab demo real-time embedded for BeagleBone Blackboard. We will focus on the third control design phase, the target, and specifically on the final validation test submode. After the RCP control design phase, we can work with the final hardware target. EICASLab provides a target operative mode allowing to export the control algorithm to the final hardware target that will execute it to control first the simulated plant in hardware in the loop, and then the real plant in final validation test submodes. EICASLab provides the routines to generate the basic software not only for the EICASLab RCP platform itself, but also for a family of devices or for a specific hardware architecture. In fact, EICASLab provides the SCG for hardware target feature, meaning automatic code generation for hardware target, aiming at generating the target-dependent source code for a set of preselected targets, such as, in this case, the BeagleBone Blackboard. The EICASLab target module for BeagleBone enables the code generation for the BeagleBone target and the upload and compiling process on it, in order to have the real-time application to run in the hardware target. Let's now consider the second submode of the target operative mode, the final validation test. In this case, the hardware target is programmed with the generated code and it commands the real plant. The EICASLab RCP platform can be suitably connected to the target to run as host PC and works as monitoring system. We consider now the system layout in final validation test submode. In the system layout, the plant model is no more needed and is disabled, because in final validation test we use the real plant. In fact, in this demo, the real plant is replaced by a plant emulator, which simulates the real plant. It is created in a separate EICASLab project. In this way, the user doesn't need to work with the real plant, which in this case is a rotating table. The control algorithm is executed, as in Hill trials, by an external hardware target, represented in the system layout by a processor block. As already said, the EICASLab RCP platform has a monitoring function. The system layout includes an extra interface block which receives data from the board. Such data can be then recorded on disk and plotted in graphical diagrams. The EICASLab RCP platform gets now a role of reference mission provider, of monitoring of the test, and runtime control of higher hierarchical level parameters. Its real-time execution capabilities are then exploited again. The control runs on the embedded board target, and the rotating table is simulated by the plant emulator. When the demo is in final validation test submode, the SCG for FVT advanced feature generates the application software and basic software for performing the final validation test, implementing the real-time communication on networking interface for data monitoring, for providing mission signals and parameters value. In this way, the EICASLab RCP platform can perform data monitoring and updating with the target. The target sends commands to the plant emulator, executed in the EICASLab RCP platform through a second instance of EICASLab demo, and the plant emulator sends measures to the target. The Target Manager tool running on the EICASLab RCP platform manages the overall final validation test trial. It is equipped with a friendly graphical user interface named Target Manager GUI, subdivided in a menu toolbar, a control panel, and 6 plotting areas for visualizing, during the real-time execution, the trends of relevant variables. So, during the trial execution, there is no physical rotating table, and the plant emulator simulates the plant and the missions. The commands are computed by the BeagleBone Blackboard and are sent to the plant emulator, which sends to the board the measures. At the same time, the EICASLab RCP platform enters in the monitor loop. It can send new values of runtime parameters to the board, while data of interest are sent back to the EICASLab RCP platform. Such data can be recorded on disk and displayed by the Target Manager GUI. For the demonstration, we need, of course, to have a BeagleBone Black board and to connect it to the EICASLab RCP platform. It is connected through a USB connection for powering on the board, and it has an Ethernet connection used for working on the board through a remote terminal and, above all, for the controlled data transfer between the board and the EICASLab RCP platform. Let's come back to the software demonstration. We let the AIG control project in the hardware in the loop submode of the target operative mode. And we have already configured through the demo configuration window the networking parameters of the demo in order to perform the networking activities between the EICASLab RCP platform and the BeagleBone Black board. Let's now move to the final validation test submode. We open the control design phase selection window and we select the final validation test. During the final validation test, the EICASLab RCP platform has a monitoring function. The system layout includes an extra interface block, the in1 block, which receives from the remote control program data packets containing the set of variables of interest that can be recorded on disk and plotted in the Target Manager GUI of the Target Manager tool. It is an Ethernet interface using the device ENP2S0 of the EICASLab RCP platform as configured in the demo configuration window and the UDP protocol. The local IP is the address of the device of the EICASLab RCP platform, and here we set the port for receiving data. Data come from the board. The remote IP is the address of the board, and it is followed by the port selected for sending data. So, in the board, we must have a corresponding interface which sends the requested data. You can see such corresponding interface opening the processor block, which represents the target, and which contains the interface out to P1 that transmits data to be monitored. For this interface, the local IP is the address of the board, and the remote IP is the address of the device of the EICASLab RCP platform used by the interface that receives the data sent by out to P1, and which is represented by the in1 block that we have just shown. Note that the sending and receiving port number correspond to the ones indicated for the in1 block. Note that the out to P1 interface is executed on the thread number 2, which has a lower priority than the closed-loop thread because it is not critical as the closed-loop activities. You can view its priority opening the global data window, selecting the physical view, opening the BeagleBone Black 1 item and the target configuration item, selecting the current threads item and clicking on the configure button. As you can see, the thread 2 dedicated to the monitoring activities has really a lower priority than the thread dedicated to the control activities. All the other interfaces establish a communication between the target and the plant emulator. For instance, the out1p1 block sends the command to the plant emulator, which, as already explained, replaces the real plant in this demo, allowing to perform final validation test trials without the real plant. It is an Ethernet interface of type network, having the role of server and using the UDP protocol. The local IP is the IP of the board, and we set here the port used for sending data. We then have to select the IP and port number of the receiver, which is always the EICASLab RCP platform since the plant emulator runs on it. Then we specify the net mask and a read timeout. The two other interfaces have the same type of parameters. Let's now perform a trial. It's a bit more complicated than in the other cases because we have now to consider three processes: the board, the plant emulator, and the monitoring activities of the EICASLab RCP platform. First of all, we export the code on the target in the same way we did for the hill. So we open the global data window, we select the BeagleBone Black 1 item and press on the LCG IS plus BS button. The LCG for target window gets open, allowing to generate the whole real-time software to export to the board. Click on the Export button. You then have to decide in which directory exporting the code. After a while, a dialog will notify that the LCG, that is the automatic code generation, is completed. After that, press on the Upload button, and the source code will be transferred to the board and compiled to a real-time binary application called bb_exe in the remote export directory. In order to proceed with the final validation test trial, we compile the project, and a compiling report of the compiling process is shown. Then we run the Target Manager tool. For performing the trial, we will have to run the already compiled board control program using a remote session on a terminal. So let's open a terminal. We have to log in as root user. Then we log in remotely to the embedded target using the Secure Shell protocol. Then we move to the remote directory selected for the code transfer. This directory contains the BeagleBone Black 1 directory that has been created during the upload process. And such directory contains the real-time application, the bb_exe file. We have now to consider the third process, the plant emulator. So let's open another instance of EICASLab demo. We open it as root user in order to use the real-time capabilities. Let's open the plant project. It is in RCP operative mode, so we have to move to the final validation test submode. In such a way, we have the final validation test configuration, having always the same plant model, but with the interfaces set for communicating with the board, while in RCP operative mode the interface communicates with the EICASLab RCP platform. Consider, for example, the in1 interface block. It receives the command from the board. So its local IP is the address of a device of the EICASLab RCP platform, where the plant emulator runs, and the remote IP is the address of the board. The ports for sending and receiving data correspond to the ones set in the RG control project. Let's now compile the project and run its Target Manager tool. Since we have to consider three processes, let's try to make it clear. We let the Target Manager GUI of the plant emulator in the upper left part of the screen, but we reduce its window. Don't forget that in standard final validation test trials, we have the real plant instead of it. We then put the Target Manager GUI of the RG control project, which has to monitor the trial, in the bottom left part of the screen. And we also reduce it. Finally, we let the terminal in the right part of the screen. We are now ready to begin the trial. So, run the BB executable. Now the control application is running, but it doesn't receive any measure, so the standard output prints a periodical reception timeout. Start now the monitoring process and the plant emulator. The trial now begins. There are no more periodical reception timeout, and the plot areas show in real time a set of significant signals. In standard final validation test trials, we have not the graphs of the plant, but we have always the graphs of the monitoring system. So, performing the control in a final configuration where the real plant and the board work, we can still monitor what is going on. To terminate the test, press Ctrl+C on the remote session for stopping the external target executable and press Stop on the Target Manager GUIs. The automatic generation of a timing report in HTML is available, and the monitored variables can be recorded to be post-analyzed by means of the POST tool. This presentation of the final validation test submode is finished. It was the last part of the webinar on the EICASLab demo real-time embedded for BeagleBone Blackboard. Thank you for your attention. More information about the demo and more generally about EICASLab are available from the online resources of eicaslab.com website. For any further information, please contact support@eicaslab.com.